Welcome to ScaleUp University. Welcome to the course on building applications with AI agents. So this is the lecture number 14 of module 1, and in this lecture we will be discussing future proofing agent systems. So first let us look at the lecture overview, like what we will be discussing in this lecture. So see, building an AI agent system is like building a house on a landscape that is shifting in real time. So the AI ecosystem, it is rapidly evolving. If I talk about the AI ecosystem's rapid evolution, so we have, like, we can see new foundation models appear every few months, like GPT-5, Llama 4. And now the problem with that is, like, with new models, previous prompt engineering or fine tuning efforts, we have to do it once again, because every new model we have to fine tune it. If let us suppose you are using GPT 3, and now you saw GPT 5 is much more advanced. Now if you are trying to migrate to GPT 5, you have to fine tune it once again. And prompt engineering also, you have to, like, do it once again for the new model. Context windows expand. So this is also something very interesting. Like, with the time we are seeing that context window is evolving, wherein the length of the input tokens which a model can take, it is increasing, like 256K. Now I think it is in millions. And with this, so traditional agentic systems, they make use of RAG, retrieval augmented generation, wherein only the a RAG helps us in getting the required context. Because of the limited context length, we made use of RAG. It helped in augmenting the context with the prompt. With the increase the context window size, like now we have models which can take multi-million token context window. No need for RAG. We can entirely fit the context, like the entire context we can fit in a prompt. Tooling standards change. So standards for agentic workflows like LangChain or AutoGen and API protocols are still in evolving phase. They are still evolving. As new patterns emerge, they are evolving. So tooling standards, it's not stable, rather it is evolving in nature. Infrastructure improves. We can see some very good improvements in the infrastructure, especially the GPUs. We are having data centers which are equipped with GPUs. Regulations evolve. So data privacy laws and AI acts, they are being written in real time, and they are evolving. So tightly coupled systems are harder to audit or modify when new compliance rules hit, and cost shift dramatically. This is very important. Like, we are seeing the token price is dropping, like it is dropping by 90% or more annually. Now the problem with this is, like, a system which was designed to save tokens at the cost of complexity may be more expensive to maintain than simply using a larger model today, because of the very, like, a significant drop in the token prices. We can afford using large models rather than going for a complex system which is more expensive to maintain. So now the idea is very clear. If I talk about AI ecosystems, it is still relatively very new. It is evolving, wherein new foundation models are appearing every few months. Context windows, it is expanding. Tooling standards, it is changing. Infrastructure improvements, we are seeing. Regulations are evolving, and cost shift dramatically. So if your agent system is tightly coupled to today's assumptions, so if the agentic system which we are designing if it is not considering this rapid evolution, then it may become obsolete tomorrow. So the idea is, so the biggest risk is not failure, because we saw that failure is something which is inevitable, which is common, and we have to make system resilience, like resilient and reliable, and we saw lots of mechanisms for that. So failure is not a risk, rather stagnation is a risk, wherein stagnation means the system you design, like let us suppose a agentic AI application you are making or any agentic AI system you are making, if it is not taking into consideration the rapid evolution of AI ecosystem, then it is stagnant, and it is more risk. It is even more risky than failure. So future proofing ensures your agent remains adaptable, competitive, sustainable, and upgrade friendly. And that is what this lecture is about. Future proofing agent systems. Now we got a very good understanding, like why this lecture is so important, because AI ecosystem, it is rapidly evolving. So whatever agentic AI systems which we are designing, the applications we are designing, we have to make it future proof, and we will learn how we can make it future proof in this lecture itself. So if we look at the topics that we will cover in this lecture, so first we'll discuss avoiding obsolescence, open standards and protocols, compatibility with future tools, scalable infrastructure choices, avoiding vendor lock-in, encouraging innovation, keeping agents relevant over time, designing for ecosystem evolution, technical flexibility, technical flexibility versus strategic flexibility, governance and compliance evolution. And finally, we will conclude this lecture by discussing anti-patterns that lead to obsolescence. So all these topics we will cover in this lecture itself. So this is the module 1, Introduction to Agents, lecture 14, Future Proofing Agent Systems. And we are starting with the first topic of the lecture, avoiding obsolescence. So obsolescence happens when, see, what is the meaning of obsolescence? First, let's understand that. It means avoiding the system from becoming obsolete, like outdated. So the goal is to avoid agent systems from becoming outdated, obsolete. So how we can avoid obsolescence? So obsolescence happens when we use old models, when your agent depends on outdated models. Infrastructure cannot support new capabilities. Because see, if we talk about modern agentic AI systems, they increasingly require vector databases, they require streaming outputs, and they require asynchronous processing. So we need infrastructure that should support these new capabilities like vector databases, streaming outputs, and asynchronous processing. Obsolescence happens when hard-coded assumptions block adaptation, and obsolescence happens when architecture cannot integrate new tools. If architecture cannot integrate new tools, then the system might become outdated, obsolete. So the idea is very clear. We have to avoid obsolescence. So to avoid this, what we should do? So we should design abstraction layers. So what it means is, like, we should make use of LLM routers, large language model routers. So the idea is your application should call a generic generate response function that should point to a central hub, allowing you to swap GBT with the cloud with a single config change. So the idea is very clear. Design abstraction layer means like hiding the internal complexity details. from the user. So the idea is user, whatever prompt he is giving, it will be routed using the LLM router. So LLM router will get a request that generate response for this prompt. Now LLM router will decide how to generate the response. Now if it feels like the prompt does not need complex reasoning, then LLM router will switch or route that prompt to a SLM, small language model. And if the LLM feels like it needs like a very complex reasoning, then it can route it to the GPT-4 or 5. So the decision is made in the background and we call it design abstraction layers. And with this, what benefit we are getting, how we are avoiding obsolescence? We are avoiding it because let us suppose you need more capabilities, like in the market after few months something very like a very innovative model, it came into picture. Very easily we can integrate it into our agentic AI system. So our agentic AI system, it will never be outdated. When it comes to models, we can keep on plugging new models. To avoid obsolescence, we should keep components loosely coupled. So we should separate, like we should use the concept of modularity. So our agentic AI system should be modular in nature, wherein we are separating the concerns, like reasoning engine will be separate, will be independent from the action layer, which is responsible for tool calling or execution. We should avoid rigid dependencies. So this is very important. So we should never hard code the tools. Rather, we should design for dynamic discovery. So in dynamic discovery, what will happen is instead of hard coding what tools are available, we should build a registry, tool registry, which will contain the list of available tools. And we should let LLM decide which tool to call. So rather than hard coding the tools, we should maintain a registry, and with this registry, it will contain the tool and its application. And very easily we can plug and play the tools from the registry, and LLM will be very flexible. Like let us suppose a particular tool is not working. So it can scan the registry and go for a alternate tool. So rigid dependencies we can avoid by dynamic discovery, designing for dynamic discovery. We should expect technological evolution and we should build systems that can observe change, not resist it. So now it's very clear that, okay, we have to avoid obsolescence in order to make our agentic AI system future proof. So we should design abstraction layers. We should keep components loosely coupled. We should avoid rigid dependencies. We should expect technological evolution, and we should build systems that can observe change, not resist it. Open standards and protocols. Close the systems, limit flexibility. So see, if your agent is built inside a black box, its growth is capped by that provider's roadmap. So open standards are like universal adapters that keep your system relevant. So see, close the systems that limit flexibility, and open standards, they are like universal adapters. They allow interoperability, wherein the agentic AI system, it can talk to different databases, different cloud providers, different external software, and that too without custom glue code for every single connection. So open standard allows interoperability, wherein our agentic AI system can interact with any open tool. Open standards allow tool integration. So using standard protocols, like when we use open standard protocols, very easily we can add new capabilities like a web search tool or a specialized calculator, just like a plug and play service. Open standards allow multi-agent coordination. So agents from different developers, they can they can only collaborate if they share a common language. So this is a very important discussion. See, for multi-agent coordination, that is possible if agents are communicating in a common language. If they share a common language, then only the communication is possible. So open standards enable agent to agent communication protocols. So open standard allows, but it enables agent to agent communication protocols. And open standard, it also allows vendor independence. Let us suppose we are going for a paid service, so that vendor, he might raise price, or we feel like the model quality is degraded. But open standards, it allows us to migrate logic to a competitor with minimal friction. So that is something very powerful. Like with open standard, we achieve vendor independence. So now it's very clear as to us that for future proofing our agentic AI systems, we should go for open standards and protocols. And if we look at examples of open design principles, like now, how we can introduce open standards and protocols in our agentic AI system. So we can do that via standardized API interfaces. So we should utilize industry standard REST patterns or gRPC patterns, so that our agent can be triggered by, or it can trigger any modern software stack. So we should use standard API interfaces. We should use structured tool schemas. Like we should adopt formats like JSON schema or open API, that's Swagger. We should go for portable model integration layers. Like we should make use of frameworks like LangChain or Light LLM, because it creates a translation layer allowing you to switch between 100 plus different LLM providers using the same code structure. So portable model integration layers. We should go for structured tool schemas that we already saw, and we should go for transparent logging formats. This is very important. So we should store execution traces in open format like open telemetry, and it will ensure that we can make use of any third-party observability tool to debug and optimize agents. So now it's very clear that, okay, how we can integrate open standards and open protocols in our agentic AI systems. So we should go for standardized API interfaces, structured tool schemas, wherein we should adopt formats like JSON schema and open API swaggers. We should have portable model integration layers, structure and transparent logging formats. And why this matters? So see, now it's very clear that open standards, it prevents your agent from becoming locked into a strict ecosystem, and open standards and protocols, they enable ecosystem participation, compatibility with future tools. So the tool ecosystem around agents is expanding rapidly. The tool ecosystem around agents is expanding rapidly. We see new APIs, new databases, new orchestration frameworks, new monitoring systems, new reasoning engines in the market. So a future proofing agent, it must support dynamic tool registration. It must allow skill expansion. It must separate tool logic from reasoning logic, and it must avoid hard-coded dependencies. So the design rule which you should follow, your agent should not need to be rewritten to use a new tool. It should simply integrate it. So that's the main philosophy. So if I talk about compatibility with future tools, so our agentic AI system should be so flexible that in order to integrate new tools, we should not be rewriting our agent. Rather, it should be plug and play. So it should be a simple integration. Like here we can see, we should not go for hard coding the tools. In that scenario, if I'm removing a tool, I have to rewrite the agent. Adding a new tool will require rewriting the agent. Rather, I should go for a modular integration. It will be future proof. So here I can see that I have an agent, and very easily I am just plugging tool A, tool B, tool C. Now I can very easily plug, unplug. So tool integration should be plug and play. Scalable infrastructure choices. So see, infrastructure plays a very important role in future proofing agentic AI systems, because infrastructure also it is evolving with time. So infrastructure decisions today affect flexibility tomorrow. So poor infrastructure choices, it create upgrade bottlenecks. Like let us suppose if your code is tied to a specific server's hardware, you cannot easily switch to the latest NVIDIA or specialized AI chips. So poor infrastructure choices create upgrade bottlenecks. It will be very tough to upgrade. It can also lead to cost explosions. Wherein, so if we are not using elastic compute, then we will be just paying the same amount of money for peak capacity as well as, so without elastic scaling, you pay for peak capacity 24 cross 7, leading to massive bills for idle resources. So this is like very important consideration. So elastic compute we will discuss in this slide itself. Deployment rigidity. So a brittle setup means every small update requires a full system shutdown, killing the rapid experimentation needed to stay competitive. So now it's very clear that poor infrastructure choices can be very dangerous. It creates upgrade bottlenecks, cost explosions, and deployment rigidity. Rather, we should go for some optimal infrastructure decisions. So if I talk about key infrastructure principles, we should always consider cloud native design, because with cloud native design, we can make use of cloud services like vector databases and message queues. We should consider containerization like the Docker and Kubernetes. So by packaging your agent and its environment together, you ensure it runs the same way on a developer's laptop as it does on a massive server cluster. This makes migrating providers or scaling up as simple as moving a file. Stateless execution where possible. So the idea is we have to design agents so they don't rely on information stored in their local memory. Because if the state, and the state is the conversation history or task progress, we have to store it in an external database. And with this, we can restart, move, or duplicate agents instantly without losing work. We should go for distributed storage, because large scale agents, they generate massive amounts of data like logs, embeddings, and traces. So using distributed systems like Amazon S3 or Google Cloud Storage, it ensures your data remains accessible even as it grows into petabytes. And we should always consider elastic compute. So in elastic compute, you will be utilizing the compute as per the need. When there will be high demand, when there will be high computing demand, you will be using resources accordingly. So that is the elastic compute. Future proof infrastructure ensures, so the goal is that we have to have a future proof infrastructure choices, scalable infrastructure choices at, and this ensures easy model replacement, geographic scaling, rapid experimentation, and resilience to traffic growth. So infrastructure choices should be in such a way that in order to make our agentic AI systems future proof, our infrastructure choices should be in such a way that it ensures easy model replacement, geographic scaling, rapid experimentation, and resilience to traffic growth. So infrastructure is the foundation of agility. Avoiding vendor lock-in. See, one of the most common long-term risk, if I talk about, it is the dependence on a single model, provider, or platform. So we should never depend on a single model provider or platform. And that is what is avoiding vendor lock-in is. And what are the consequences? Like if you depend on a single model provider or a single platform, what risks are associated with that? Price, pricing vulnerability, technical stagnation, because that provider or that platform, it might not be evolving. Limited feature flexibility, you might feel getting stuck. And migration difficulty, it's hard to leave. So we should never depend on a single model. So what is the way forward? Like what are the strategies, solutions for that? So strategies to avoid lock-in. So what we should do is we should abstract model access behind interfaces like API gateway and wrapper. So as we already saw, we should have a LLM router in place. So whatever incoming request, based on the nature of the request, we should route it to a particular model. And because of this interface, very easily we can plug and play whatever models we want. So here we are avoiding dependency on a single platform. Rather, we are telling that whenever you are designing an agentic AI system, just don't use one model. Rather, use multiple models, like use SLMs, small language models, use large language models, LLMs of different providers like ChatGPT, Gemini, Claude, support multiple model backends. So that is what just now we discussed. Avoid proprietary orchestration frameworks without escape paths. Go for open standards. Keep data portable, like make use of standard formats like JSON and Parquet. So flexibility equals bargaining power. Because if your agentic AI system is flexible, you can bargain. And how you can bargain is, let us suppose some low cost model is launched in the market. Very easily you can plug it in your agentic AI system because your agentic AI system is flexible. So you should avoid dependency on a single model or model provider or platform. That's the goal. Encouraging innovation. Okay, so if I talk about future-proof systems, they do not just survive, rather they evolve also. Because if I talk about future-proof systems, it is not about just surviving the rapid AI evolution, rather evolving also. Agentic AI system, it should keep on evolving with the evolution of AI ecosystem. So the goal is very clear, and that is what is encouraging innovation. So our agentic AI systems, it should also keep on innovating. So encouraging innovation requires modular design, because we already saw that in modular design, we can rapidly experiment with individual modules, components separately. And modular design enables very fast iterations and rapid innovation. So encouraging innovation requires modular design. It requires experiment-friendly architecture. It requires safe testing environments, clear version control, and A/B experimentation capabilities. So an agent system should make it easy to experiment. So our agentic AI system should be designed in such a way that experimentation should be easy. Our agentic AI system should be experiment friendly, wherein we can try new reasoning strategies, we can test new models, we can experiment with multi-agent coordination, and we can explore new domains. So rigid systems, they discourage progress, and flexible systems, they accelerate progress. Because with rapid innovation, if our agentic AI system is also innovating, it is evolving, then it is accelerating, keeping agents relevant over time. So, see, in the AI economy, an agent's value decays the moment it stops reflecting the real world. Because we already saw the real world is changing very rapidly. The real world, the world around us is very uncertain, it is changing. So, if agent is not reflecting, if agent is not considering the real world changes, then it will start decaying. So relevance isn't a static achievement, it is a constant maintenance of the fit between the agent's intelligence and the environment it serves. So the idea is, it's like, let us suppose you have a very intelligent agent, but if it is not relevant, like if it is not updating or maintaining the fit with the real world changes, then it will start becoming irrelevant. So if I talk about agent relevance, so agent is relevant. So I can measure the agent's relevance based on the performance of the agent. And performance is not just about accuracy, it's also about latency and cost efficiency. So let us suppose if a question can be answered in 2 seconds, and if our agent is taking 30 seconds to answer that question, then our agent is irrelevant, regardless of its intelligence. So relevancy of an agent depends on its performance. Adaptability. So adaptability is the ability to pivot. So let us suppose if your company switches from Salesforce to HubSpot, can your agent learn the new interface overnight, or does it require a total rebuild? So that is the adaptability. So now it's very clear to us that whatever agents we are designing, we have to keep it relevant over time. And how we can do it is we should keep on monitoring its performance. And if we feel like its performance is degrading with time, we have to work on that. We have to optimize the performance. We have to make our agent adaptable, because with time, things are changing and our agent should be adaptable. Trust. Trust is very important. So users must believe the agent is grounded in truth. Relevance dies the moment an agent confidently hallucinates. So agent is relevant as long as it is giving the right answers, or if it is making mistakes also, or if it is not confident, it has to be very frank and clear that okay, this is the problem I'm facing, or this response, like I'm not sure about it, like that. So agent is relevant till the time we have trust in it. Once we lose trust, agent's relevance is gone. So trust is very important. Regulatory compliance. Okay, so frameworks like the EU, like European Union AI Act or NIST AI Risk Management Framework change how data must be handled. So we see regulatory compliance, they keep on evolving. So a relevant agent must be compliant. So our agent is relevant, our agentic system is relevant if it is following those compliance. And integration capability. So our agentic system, it must stay compatible with evolving enterprise tech stacks and API versions. Then we will say that it is relevant. So keeping agents relevant over time is very important. So we have to keep on monitoring its performance. Our agentic system should be adaptable, trust should be there, regulatory compliance, and integration capability. So agents, they must update knowledge sources. So they must make use of dynamic RAG to pull out live documentation rather than relying on training data that cut off 2 years ago. So agents, they must keep on updating their knowledge sources. They must make use of dynamic RAG. They should integrate evolving business rules. They must adapt to new regulatory requirements, and they must maintain transparency. Like we should use traceability tools like Langsmith or Phoenix. So humans can audit why an agent made a specific decision. And if I talk about long-term relevance, it requires continuous improvement loops. So we should implement human in the loop workflows where edge cases are flagged, reviewed, and used to teach the agent through few short prompting or fine tuning. Long term relevance requires clean governance structures like version control for prompts and a kill switch for when model updates lead to unexpected regressions. Long term relevance requires monitoring and audit systems. So, building automated dashboards to track drift. And long term relevance requires upgrade pathways. We should treat every component as a module. So, your vector database like Pinecone or LLM provider should be swappable via an abstraction layer to avoid being tightly coupled to a sinking ship. So, relevance is very important. So, relevance is the shield against obsolescence. Designing for ecosystem evolution. See, agents will not operate alone in the future. Rather, agents they will interact with, they will operate in an ecosystem wherein they will be interacting with other agents. Agents will be interacting with enterprise systems. Agents will be interacting with monitoring services. They will be interacting with regulatory platforms and they will be interacting with data ecosystems. So if I talk about an agent, it will not operate in isolation. Rather, it will be operating in an ecosystem wherein it will be interacting with other agents, enterprise systems, regulatory platforms, data ecosystems, and monitoring services. So, future proof design must anticipate multi agent collaboration, interoperability, shared protocols, and decentralized coordination. So, the key idea is closed systems will struggle in open ecosystems. So the idea is the agentic AI systems you will be making in order to make it future proof, you have to design it for ecosystem evolution, wherein it should be very easy for it to interact or operate in the ecosystem because agent will not be operating in isolation. So multi-agent collaboration, interoperability, shared protocols, and decentralized coordination. So these are the keys. Technical flexibility versus strategic flexibility. So we have two types of flexibilities. So if we talk about technical flexibility, we are talking about swappable models. We are talking about modular tools and we are talking about scalable infrastructure. So models should be swappable, tools should be modular wherein plug and play capabilities and infrastructure should be scalable. So that is a technical flexibility. Similarly, we have something called as strategic flexibility, wherein we are talking about ability to pivot use cases, adapt to business shifts, integrate new workflows, support emerging regulatory standards. So these are strategic flexibility. So future proof systems, they address both the technical flexibility also and the strategic flexibility also, wherein they can very easily swap models. Very easily we can add new capabilities, add new tools, remove tools. We can scale the agentic AI system. Now agentic AI systems, they have the ability to pivot use cases like any updations in the business requirements that can be taken care of, adaptation to business shifts, integrating new workflows, and supporting emerging regulatory standards. So these are like strategic flexibility. So future proof systems address both governance and compliance evolution. So AI regulation is expanding globally. So agents, they must remain transparent, compliant, auditable, and controllable. So the future-proof designs, it includes audit logs, decision explainability, access controls, and policy enforcement layers. So ignoring governance today leads to forced redesign tomorrow. So now it's very clear to us that future-proof agentic AI systems, they also have to take into consideration the governance and the compliance, because AI regulation, it is expanding globally. So agentic AI systems, they must remain transparent, auditable, compliant, and controllable. And future-proof design includes audit logs, access controls, decision explainability, and policy enforcement layers. Anti-patterns that lead to obsolescence. So these anti-patterns we should avoid, like hard-coded prompt logic, single provider model dependency, no abstraction layers, monolithic design, no upgrade strategy, ignoring regulation. And the best practices we should follow is model abstraction, tool registries, modular architecture, elastic infrastructure, continuous improvement mechanisms. So finally, we completed this lecture. So in this lecture, we saw why obsolescence is a real risk, how open standards increase longevity, why avoiding vendor lock-in matters, how infrastructure choices affect adaptability, and how innovation and governance preserve relevance. So future proofing is not about predicting the future. It is about designing systems that can adapt to unknown changes, integrate unknown capabilities, and survive unknown disruptions. So the future of AI agents is uncertain. Your architecture should not be uncertain. Your architecture should be future proof, wherein it should be capable of handling those uncertainty. So I hope you got a very good understanding of the concepts that we covered in this lecture. So do subscribe to our YouTube channel, Scale Up University, for more such interesting lectures and courses. Thanks for watching. Thanks for your time.